Hello, it's Mrs. Morehouse. I'm going to be showing you some different multiplication strategies. The very first strategy I'm going to teach you that I personally enjoy the most is an array. I'm going to first start out with an easier problem just to show you how it works, and then I will go into a harder problem, and then I'll continue to use the harder problem for the rest of the strategies. So the very first problem I'm going to show you is 13 times 4. So the idea with this strategy is to split up the tens and the ones so that you can multiply easier problems. So the 4 is ones, but the 13 is a 10 and a 3. So what you do is you create a rectangle box and you split it down the middle. You're splitting it down the middle because you're going to have your 10 on one side and your 3 on the other. And together, 10 and 3 make 13. On the other side of your box, you're going to place the 4. So kind of what you're doing is like creating a floor plan, and you're saying that this room is a 10 by 4 and this room is a 3 by 4. And then you're finding the area. So 4 times 10 is 40, and 4 times 3 is 12. And then you simply add up the numbers in the middle, and 40 plus 12 is 52. Now this is how I started teaching this strategy, but we've moved on to harder numbers. And actually I might be showing you 3 just so you can really get the hang of it. I'm going to show you 36 times 8. Students are more than welcome to do the 30 as a 10, a 10, and a 10 if they want. But eventually what we want to do is teach them all of the standard multiplication problems like 8 times 3 so that you can keep the 30 and the 6 and then do the 8. How I teach it in my class is I say 8 times 3 is 24, and I add that 0, just like that. Then I say 6 times 8 is 48, and I add up the middle just like I did before, and my answer is 288. The last problem that you could be solving using the array is a double by double. And actually, I guess you could go even bigger, but that might get messy. So if I were to say that I wanted to do 25 times 17, now I'm going to create a rectangle that has 4 different quadrants in it. Because this is the 25, and then the other side is a 17. So 2 times 1 is 2, and I have a 0 here and a 0 here, so I'm going to add 2 zeros. 5, now we all know 10 times 5 is 50, but 5 times 1 is 5, and there's only 1 0. 7 times 2 is 14, and there's 1 0 showing, so I add that. And 7 times 5 is 35. Now, I can rewrite all of these numbers over here and add them up. But sometimes I encourage students to do some mental math. And I know that 200 plus 140 is 340. And 50 plus 35 is 85. 0 plus 5 is 5. 4 plus 8 is 12. I put the 2 here. I am in the tens column. So I bring the 1 up into the hundreds because that is a 100. And 3 plus 1 is 4. So those are 3 different problems that you can do with the array that aren't overly difficult. You just need to practice them and become comfortable with them. But I'm going to stick with this problem here for the rest of my strategies, 36 times 8. So the next strategy is a ratio table. The thing about a ratio table is you do not need to count from 1 all the way up to 36, and I'll show you how. I'm multiplying 36 times 8. I'll even write it down here so we remember. 36 times 8. Now this is a 30 and a 6. And I'll show you how you can kind of use the numbers to your advantage and make this problem a lot easier. I put a 1 on this side and I say 1 times 8. So it's an imaginary, you know you're multiplying all of these numbers by 8. 1 times 8 is 8. Now I do know I have a 6 here, so I might say that 5 times 8 is 40. Remember this 6, because if you look here, 5 plus 1 is 6, correct? If I can add 5 plus 1 is 6, I can add these two numbers and get 48. Now for the 30. Let's pretend like 30 times 8 is really scary for the kids. So I do a 10. 10 times 8 is 80. What about a 20? 10 doubled is 20. If I can do that, then I can double this. 80 doubled is 160. And this is the thing that is, I think, the hardest for me in teaching math, is I want students to start being aware of the work that they've done and the numbers that they're working with. This is a 30. I know I need to eventually get to 30 times 8. Well, what's sitting right here? A 10 and a 20. 10 plus 20 is 30. So I can add these two. So I know that's a 0. This is 14 and it's 240. Lastly, my work is done. Some students may not know this, but it's pretty much done. I know this because I'm doing 36 times 8. I have a 30 here and a 6 here. All I have to do is add 30 plus 6 is 36, which means I can add 48 and 240. And that makes it 288. And this is my answer. The last one is a number line, which I wouldn't recommend for this problem. And I have seen students try to do a number line with this big of a number. But let's play with it a little bit. I mean, some students, they'll blow your minds with some of their ideas. So I'm going to try it out. What if I did 36 divided by 2? It's 18. Some students really would want to count from 0 and count by 8s all the way to 18 times. I just don't know if that would take a long time, and there's a big probability of making a mistake. So I mean, you'd be going well over 80. So I don't think 36 times 8 would be a smart choice in using a number line. So let me show you how to use what I was going to do. I was going to count by 8s to 18, and whatever number I got, I was going to double. And if students are thinking that way, that's kudos to them. That's a really good job, especially at the 4th grade level, for them to be able to manipulate the numbers and understand what they're doing. That's a good job. But let's do, let's say that a student is struggling with their standard multiplication skills. So I'm going to say 8 times 4. That could be a tricky one for kids. So I just want to show you how the number line works in multiplication. You always start at 0 and you count by 4s. So you have 4, 8, 12, 16, 20, 24. Let me know if I miss a number. 28, 32, 36, and then 40's way out here. I counted by 4s. I've done this. So now all I do is jump 8 times. So I start at my 0. The reason why it's so important to start with the 0 is because that's your first jump, and you just count 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my answer. So if you didn't watch the subtraction video, I tell students that not all of these strategies are good strategies for every single problem they run into. These strategies are supposed to be available for them, and depending on what the problem is, they can make a good choice on which strategy they think would work best for them. So as you can see with the 36 times 8, the number line, it wasn't a good idea. I'm not saying a student wouldn't try it, but to ask a student to count by 8 all the way 36 times, that would take forever.